Fun. I am Komal. So in the last video we discussed about traditional application delivery model and we discussed what are the disadvantages of it. Then we came to cloud delivery model and there also we saw that a better way to provision the infrastructure is by codifying the whole application delivery process, and there comes infrastructure as code. In IAC tools, we can provision the infrastructure, we can manage it, we can destroy the infrastructure, everything using a single file through code. How cool, right? Terraform is one such infrastructure as code tool, and through it we can create, manage and destroy infrastructure in just a matter of minutes. This is the second video in the whole tutorial series, and in this video I will be introducing you to Terraform, which is an IAC tool, and we will see how a Terraform configuration file looks like and how to install Terraform, what is HCL, which is HashiCorp configuration language, and what are the Terraform commands, how do we run all those commands, the HCL basics basically. So we will cover everything in this video, so let's get started. Also, if you are new to the channel, please subscribe. We put on amazing new videos related to tech and travel every weekend. You'll get to see many new things here and they'll all be interesting. So please subscribe.
Terraform is a free and open source tool which is developed by HashiCorp. It installs as a single binary which can be set up very quickly, allowing us to build, manage and destroy infrastructure in a matter of minutes. So how does Terraform manage infrastructure on so many different kinds of platforms? This is achieved through providers. A provider helps Terraform manage third-party platforms through their APIs. Basically, you can consider it as an interface between the Terraform user and the backend, which is the APIs. For example, if I want to create an EC2 instance in AWS, I will connect to the AWS provider provided by Terraform. Likewise, it has almost hundreds of providers with which we can work with almost every infrastructure platform. Terraform configuration files look something like this. The language is HCL, which stands for HashiCorp Configuration Language, which is a simple declarative language to define the infrastructure resources to be provisioned as blocks of code. All the infrastructure resources can be defined within the configuration file that has a .tf file extension. The configuration syntax is very easy to read and write. And this is the sample code which is used to provision an EC2 instance on the AWS cloud. This code is declarative and can be maintained in a version control system, allowing it to be distributed to other teams. Now, we will cover the HCL syntax in more detail later in this tutorial. So as I said, that the code is declarative, but what does declarative mean? The code we define in this file is the state that we want our infrastructure to be in. So that is the desired state. And this on the right is the current state of the cloud where there is nothing. Terraform will take care of what is required to go from the current state to the desired state without us having to worry about how to get there. So how does Terraform do that? Terraform works in three phases: init, plan and apply. During the init phase, Terraform initializes the project and identifies the providers to be used for the target environment. During the plan phase, Terraform drafts a plan to get to the target state. And then in the apply phase, Terraform makes the necessary changes required on the target environment to bring it to the desired state. If for some reason the environment was to shift from the desired state, then a subsequent Terraform apply will bring it back to the desired state by only fixing the missing component. Every object that Terraform manages is called a resource. A resource can be a compute instance, a database server in the cloud, or in a physical server on-premise that Terraform manages. Terraform manages the life cycle of resources from its provisioning to management to decommissioning. Terraform records the state of infrastructure as it is seen in the real world, and based on this, it can determine what actions to take when updating resources for a particular platform. Terraform can ensure that the entire infrastructure is always in the defined state at all times. The state is a blueprint of the infrastructure deployed by Terraform. It can read attributes of existing infrastructure components by configuring data sources. This can later be used for configuring other resources within Terraform. Terraform can also import other resources outside of Terraform that were either created manually or by the means of other IAC tools and bring it under its control so that it can manage those resources going forward. Therefore, Terraform makes an excellent enterprise grade infrastructure provisioning tool. Well, that was a quick introduction to Terraform at a high level, so let's dive in and explore all of these in much more detail. Terraform can be downloaded as a single binary or an executable file from the Terraform download section in www.terraform.io. Please check all the necessary links in the video description below. I'll be attaching them there. Installing Terraform is as simple as downloading this file and copying it to the system path. Once installed, we can check the version by running the command terraform version. Terraform is supported on Windows, Mac, and several other Linux-based distributions. Please note that all the examples shown in this video will make use of Terraform running on a Linux machine and specifically the version 0.13. And that's it. We can now start deploying resources using Terraform. As stated earlier, Terraform uses configuration files which are written in HCL to deploy infrastructure resources. These files have a .tf extension and can be created using any text editor or any IDE of your choice. So, what is a resource? A resource is an object that Terraform manages, and therefore it could be a file on a local host, or it could be a virtual machine on the cloud, such as an EC2 instance, or it could be services like S3 buckets, ECS Dynamo DB tables, group roles, policies, etc. Or it could be resources on major cloud providers such as the Compute and App Engine from GCP, databases on Azure, Active Directories, etc. There are literally hundreds of resources that can be provisioned across most of the cloud and on-premise infrastructure using Terraform. We will look into some of these examples later in this course, but for the first few sections, we will stick to two very basic and very easy to understand resources: the local file type of resource and a special kind of resource called a random pet. It is important to use a simple resource type to really understand the basics of Terraform, such as the life cycle of resources, the HCL format, etc. Once we gain a good understanding of the basics, we can easily apply that knowledge to other real life use cases, and we will see that in later sections of this course. Let's understand the HCL syntax. The HCL file consists of blocks and arguments. A block is defined within curly braces and it contains a set of arguments in key value pair format, representing the configuration data. But what is a block and what arguments does it contain? In its simplest form, a block in Terraform contains information about the infrastructure platform and a set of resources within that platform that we want to create. For example, let's consider a simple task. We want to create a file in the local system where Terraform is installed. To do this, first let's create a directory called terraform-local-file under the /root directory. This is the directory under which we will create the HCL configuration file. Once we change into this new directory, we can create a configuration file called local.tf. This .tf file is the only file that the Terraform user will have to manage throughout the lifecycle. And within this file, we can define a resource block like this. And inside the resource block, we specify the file name to be created as well as its contents using the block arguments. Let us break down the local.tf file to understand what each line means. The first element in this file is a block. This can be identified by the curly braces inside. The type of block we see here is called the resource block. And this can be identified by the keyword called resource in the beginning of the block. Following the keyword called resource, we have the declaration of the resource type that we want to create. This is a fixed value and depends on the provider where we want to create the resource. In this case, we have the resource type called local file. A resource type provides two bits of information. First is the provider, which is represented by the word before the underscore. In the resource type here, we are making use of the local provider. The word following the underscore, which is file in this case, represents the type of resource. And the next and final declaration in this resource block is the resource name. This is the logical name used to identify the resource, and it can be named anything. Terraform uses it internally to identify the resources. But in this case, we have called it pet, as the file we are creating contains information about pets. And within this block and inside the curly braces, we define the arguments for resource, which are written in key value pair format. These arguments are specific to the type of resource we are creating, which in this case is the local file. The first argument is the file name. To this we assign the absolute path to the file we want to create. In this example, it is set to /root/pets.txt. The second argument is content. To this, let us add the value we love pets. The words file name and content are specific to the local file resource we want to create, and they cannot be changed, in other words. The resource type of the local file expects that we provide the argument of file name and content. Each resource type has specific arguments that they expect. We will see more of that as we progress through the course. And that's it. Yeah. Now we have a complete HCL configuration file that we can use to create a file by the name of pets.txt. This file will be created in the /root directory, and it will contain a single line of data. The resource block that we see here is just one example of the configuration blocks used in HCL, but it is also a mandatory block needed to deploy a Terraform resource. This is one example of a resource file created for provisioning an AWS EC2 instance. The resource type is AWS_instance, and we named the resource web server, and the arguments that we have used here is the AMI ID and the instance type. Here is another example of a resource file used to create an AWS S3 bucket. The resource type in this case is AWS_S3_bucket, and the resource name that we have chosen is data. And the arguments that we have provided are the bucket name and the ACL. A simple Terraform workflow consists of 4 steps. First, write the configuration file. Next, run the Terraform init command. And after that, review the execution plan using the Terraform plan command. Finally, once we are ready, apply the changes using the Terraform apply command. With the configuration file ready, we can now create the file resource using the Terraform command as follows. First, run the Terraform init command. This command will check the configuration file and initialize the working directory containing the Terraform file. One of the first things that this command does is to understand that we are making use of the local provider. Based on the resource type declared in the resource block, it will then download the plugin to be able to work on the resources declared in the .tf file. From the output of this command, we can see that Terraform init has installed a plugin called local. Next, we are ready to create the resource. But before we do that, if you want to see the execution plan that will be carried out by Terraform, we can use the command terraform plan. This command will show the actions that will be carried out by Terraform to create the resource. Terraform knows that it has to create the resources, and that is displayed in the output similar to a diff command in Git. The output has a plus symbol next to the local file type resource called pet. This includes all the arguments that we specified in the .tf file for creating the resource, but you will also notice that some default or optional arguments which we did not specifically declare in the configuration file are also displayed on the screen. The plus symbol implies that the resource will be created. Now remember, this step will not create the infrastructure resource yet. This information is provided for the user to review and ensure that all the actions to be performed in this execution plan are desired. Now after the review, we can create the resource, and to do this, we will make use of the Terraform apply command. This command will display the execution plan once again, and it will then ask the user to confirm by typing yes to proceed. Once we confirm it, it will proceed with the creation of the resource, which in this case is a file. We can validate that the file was indeed created by running the cat command to view the file. We can also run Terraform show command within the configuration directory to see the details of the resource that we just created. This command inspects the state file and displays the resource details. We will learn more about this Terraform show command and the state that I'm talking about in upcoming videos. So congratulations, we have now created our first resource using Terraform. Before we end this section, let us go back and look at the configuration blocks in the local.tf file once. In this example, we used the resource type of local file and learned that the keyword before the underscore here is the provider name called local. But how do we know? How do we know what resource types other than local file are available under the provider called local? And finally, how do we know that what arguments are expected by the local file resource? Don't worry, I'll cover everything, but in the next video.
Thank you for watching this video. If you like this, please like, comment, share and subscribe to our channel. In the next video, I will be talking about in-depth knowledge of providers and all the Terraform commands. How do they work? When do we use which command and everything in detail. So please wait till the next video comes out. Bye!